Alright, so this is going to be a lesson on 1.2, distance versus displacement. So here's the Google Slides and here's the Google Docs. Those are your notes. So you have this question here, and it says I throw a handball towards the wall, and some students say I threw it to the right, and some say I threw it to the left. And so how is this possible, right? Because this definitely is possible. Let's take a look. Let us say this is the board. Let's say we're in a classroom, right? Let's say we're in a classroom and this is the board at the front of the room, right? And here's the door. Not sure how to draw a door, right? But there's the door to the classroom. Again, don't know how to draw a door. Let's say you have two students, and this student is facing this way. And this student is facing that way, right? So they don't know how to draw, right? They're facing that way. And let's say I'm here. Let's say I'm there. Let's say I throw a ball towards the whiteboard. Say I throw a ball towards the whiteboard. This guy on the right, well, which direction does he think I threw the ball in? Well, this direction is to the right, to his right. What about the guy on the left? Well, he or she thinks that I threw it to the left, right? I threw it to his left, and on the other person on the right-hand side, I threw it to his right. It really, in the end, it depends on the perspective of the observer. Right? It depends on the perspective of the observer. So this is definitely possible. Moving on, we're actually going to skip this video. You can watch it on your own time. You can also watch this on your own time. And I want you to copy this down, frame of reference. Okay, so number one, frame of reference. Right, so frame of reference over here. I want you to copy this down. So take some time to do it. Pause this video. All right. Then I'm going to introduce to you now the next question here. And so the next question is says, I travel a total distance of 5 meters, but I only ended up 1 meter from where I started. Well, how is this possible? Again, so let's take a look. Well, this is definitely possible because you don't need to walk in a straight line, right? I can walk 3 meters up and 2 meters down, and I travel a total distance of 5 meters, sure, but I was only 1 meter away from my starting position, from my initial position. Furthermore, I can also travel in a circle, right? Or I can take a detour, right? I can travel in a circle. Sure, I might travel like 5 meters here. Again, it did not draw on the scale. I might have traveled 5 meters, but how far am I from my original position? Well, I'm only 1 meter away. Right? I can also take a detour, right? So we'll just go this way, and then there. Sure, this might be 5 meters, but this was only 1 meter. Again, I don't draw things to scale. Moving on. So that's that. So make sure to write something here. Distance versus space. So now you need to actually write, right? You need to copy these notes down over here on this page. And now I'm going to introduce you to two different units. I mean, rather, two different quantities. One of them is called distance, and the other is called displacement. And you can clearly see on the image here. It's actually just snip this. You can see it on the image. This clearly tells you, right? So this image right here. This clearly tells you the difference between distance and displacement. Distance is the total length of your path traveled, which basically means your total ground covered. Displacement, on the other hand, is actually how far you are from your initial starting position. It is essentially your final position minus your initial position, right? Where you end and where you start. Where you end and where you start. Now, displacement is a vector quantity. Why? Well, if you recall from the last lesson, right, lesson 1.1, vectors have direction. Vectors have both magnitude and a direction. You need a direction for your displacement. Otherwise, you don't know where you end up. Right? It could be, well, let's say I'm 1 meter from where I started. Well, 1 meter from where I started, let's say, for example, this dot, actually, 1 meter from where I started, say I start here. 1 meter from where I started could be here, could be there, it could be over here, could be here. We need an exact point for our displacement. And so we can say, well, we're 1 meter southeast of where we started. And so there's a direction here. We need a direction for displacement. And we need a direction for displacement. Distance, on the other hand, distance is a scalar. You don't care which direction you went in, right? I could have went this way, this way, this way, this way, then this way, and then this way. But in the end, I'm just adding up the total length traveled. I don't care if I went north, south, east, west. I don't care about my direction. I just care about my total ground covered. And so distance is a scalar quantity. All right, moving on. What is next, actually? Oh, example problems. So, to example problems. So let's say I chase after an ice cream truck. Okay, let's say I chase after an ice cream truck to the west for 50 meters. I buy ice cream, and then I walk back east 10 meters. And your first question here is, well, what is my total distance traveled? Well, we don't care about direction yet. So my total distance traveled is 50 plus 10, right? That gets me 60 meters. So my total distance traveled here is 60 meters. The only thing I'm doing is I'm adding up both my distances, both my lengths. Displacement now, well, that's a bit trickier. So if I first travel 50 meters to the west, so let's draw it. So let's start at 0. Right, we start at 0. I travel 50 meters to the west. And then I walk back east 10 meters. And I end up here. So what's the difference here? What's the difference here, right? How far am I from my original starting position? Well, it's going to be 40, right? I'm 40 meters away. So I'm 40 meters away. But displacement is a vector. Displacement is a vector. Which means, right? Which means that I must include direction. Where did I end up in relation to my initial position? where is my final position in relation to my initial? Well, my final is east, I'm sorry, is west of my initial position. Right? So we're going to say 40 meters west. And so this would be an appropriate answer, right? So displacement is a vector, which means you must have direction. Let's do another practice problem. And you should follow along on your notes. All right. So a ball rolls 3 meters to the left, and the student kicks the ball 5 meters to the right. So what is the ball's total distance traveled? Well, the only thing you're doing here, right? You're doing 3 meters plus 5, because that's the total distance, is 8 meters, right? So the student kicks the ball. Well, now we're about displacement. Well, let's draw on this graph. So let's start at 0. We always start at 0. A ball rolls 3 meters to the left. And the student kicks the ball 5 meters to the right. So the ball is 5 meters to the right. And so we end up here. And so this is our final position. Well, what's my ball's displacement? How far am I from my initial position? Well, I'm 2 meters from my initial position. Well, we'll also have to add the direction, right? My final position is east of my initial. All right? My final position is east of my initial position. It's where I ended up. Move on. Now, this is something extremely important in physics. Let me just clip this. In math, you're taught that a number like -7 is less than 0 and is less than 7, right? You're taught this, and it makes sense for you. You've been taught this in math. But that's not what that means in physics. A negative 7 in physics does not necessarily mean it's less than 7 or greater than 7. A negative sign, the only thing a negative sign means in physics is that the negative sign is the opposite direction of your positive sign. But then what's the direction of my positive sign? Also remember in math, right? We did if you ever drew a plot, right? If you ever drew a plot, you know that, well, to the east and north is positive and south and west is negative. But there's a very specific reason why I said that the negative sign is the opposite direction of the positive. Because we don't assume the positive direction to be anything. Unless we're told that the positive direction is east, right, north, or up, we can't assume anything. Which is why we say that the negative sign is the opposite direction of the positive. And this is the true definition of the negative sign. Let's say, for example, our positive direction is north. And let's say our positive direction is north. Well, then my negative direction is south. And if my positive direction is left, then my negative direction is to the right. Our positive direction is usually going to be right and east. I cannot recall other than 2 regions questions where the problem had you assume left and west was positive. For a majority of questions, right, east, up, and north will be positive. But for the questions that don't adhere to the most common assumption, where right and east is positive, well then you have this direction. You have this definition. A negative sign is the opposite direction of the positive. One nuance here is that, well, negative 6 meters represents 6 meters south. And that's enough. That's called a vector, right? A vector has both direction and magnitude. The negative sign is all you need for a direction. The negative sign is all you need for a direction. But on the other hand, if you write positive 6 meters, that is not direction. That does not indicate direction. The only thing positive 6 meters means is 6 meters. There is no direction associated with it. Why is this? Well, again, we can't assume the positive direction to be anything. But we can assume that the negative direction is the opposite direction of the positive, which means that the negative sign is direction, whereas the positive sign written like this is not. You also cannot say negative 7 meters left. That's a double negative. That's impossible. You cannot have that answer. So let's do a practice question. Okay. Let's say I walk to the door 5 meters to the right, and known to pace back and forth, I walk 6 meters back to the left. So what is my total distance traveled? We're going to do 5 plus 6, right? So that's my total distance, and that's 11 meters. Now, what is my displacement? Now, we're going to do this a little bit different. We're going to do this without a graph. 5 meters to the right. We're going to assume that's positive. And known to pace back and forth, I then walk 6 meters back to the left. So this is the opposite direction now. This is the opposite direction of your right. So that's going to be negative. So we're going to do minus 6 meters. And then in the end, we get negative 1 meters. So we are negative 1 meters away from my initial position. Essentially, you're saying I'm 1 meter left of my initial position. Let's confirm it. Let's say I start here. Go 5 meters to the right. And then I go 6 meters to the left. And yes, I do end up at negative 1. So I'm negative 1 meters away. This is correct. Displacement is a vector. And this negative sign right here is enough for a direction. Alternatively, you could have written 1 meter left. Either is fine. Either or. But you cannot write negative 1 meter left. This is a double negative. Let's do another practice question. I travel 30 meters to the east and travel 40 meters to the west. My total distance traveled is 70 meters, right? We don't care about direction here because distance is a scalar. Scalar only has magnitude. What is my displacement? So 30 meters to the east is positive 30, right? We're assuming positive direction to be east. And then I travel 4 meters to the west. And so that's going to be negative, right? It's in the opposite direction. So here we have negative 10 meters. And again, this is enough. We don't need to say left, east, west here. The negative sign is enough. Let's move on to another practice question. A train runs 3,000 meters south, right? So we're going to say this is a train runs 3,000 meters south. So well, we're going to do distance first. What's my total distance traveled? 3,000 plus 4,000 gives us 7,000 meters. Was the displacement? So we're going to assume south to be negative, right? So we're going to do negative 3,000. And north to be positive, so plus 4,000. So we get 1,000 here, 1,000 meters. But we're not done. We need a direction. We don't have a negative sign anymore. Displacement is a vector, which means we need a direction here. And we need a direction. So now to finish this, to write the correct answer, it's going to be 1,000 meters north. I'm 1,000 meters north from where I started. So 1,000 meters north. And this is the answer. Next. Nothing's next? Okay.